How does selectivity work in relay protection systems? Imagine a power system where a fault occurs, like a short circuit or overload. How does the system know which part to disconnect without shutting down the entire network? That's where selectivity in relay protection comes into play. Selectivity means that only the section with the fault gets disconnected, leaving the rest of the system running smoothly. It's like a smart filter that isolates problems without causing unnecessary outages. When a fault happens, the protective relay closest to the fault should trip first. This way, only the affected part is turned off and the rest keeps supplying power. For example, if a fault occurs on a specific feeder in a distribution network, the relay protecting that feeder should trip first. The main circuit breaker that supplies the entire network should stay on unless the fault is severe. This setup helps keep the system stable and reduces downtime. Achieving selectivity involves setting the relays and circuit breakers carefully. Each device is assigned a specific zone of protection. The relay nearest to the potential fault has the lowest current threshold and the fastest response time. If it doesn't clear the fault, backup relays further upstream are set to trip after a delay. This layered approach ensures that faults are cleared efficiently without affecting the whole system. There are different types of selectivity. Total selectivity guarantees that only the faulty section is isolated, no matter how big the fault is. Partial selectivity works well up to a certain level of fault current. Beyond that, multiple relays might trip, causing wider outages. In real-world power systems, especially those with many interconnected parts like renewable energy plants or large industrial setups, selectivity is vital. Engineers use time-current curves and coordination studies to make sure relays operate in the correct order. They consider system complexity, fault conditions, and the need for quick fault clearance. Selectivity is one of the main properties of relay protection, along with speed, sensitivity, and reliability. When designed properly, it helps keep the power system stable, reduces outages, and improves safety by quickly isolating only the faulty parts. So, in simple terms, selectivity makes sure that when something goes wrong, only the part that's broken gets shut off, keeping everything else running smoothly and safely.